As a point of interest, I'm going to explore the relationship between the sum and product of the zeros of a quadratic polynomial and the quadratic formula. Let alpha and beta be the zeros of the quadratic polynomial p of x equals ax squared plus bx plus c, and the roots of the quadratic equation p of x equals 0. So we have our two roots, alpha and beta. Alpha is equal to negative b minus the square root of b squared minus 4ac over 2a, and beta is equal to negative b plus the square root of b squared minus 4ac over 2a. Now if we add the two roots together, so alpha plus beta, so we're adding negative b minus the square root of b squared minus 4ac over 2a plus negative b plus the square root of b squared minus 4ac all over 2a, you'll get some cancellation. The third component cancels out and you're adding negative b on 2a to negative b on 2a, and then you end up with negative b on a. So alpha plus beta is equal to negative b on a, and we've seen that before. Now multiplying the two roots is a little bit more complicated, but not so much more. If we take negative b minus the square root of b squared minus 4ac over 2a and then multiply it by negative b plus the square root of b squared minus 4ac all over 2a, we factorise out the 1 over 4a squared, so that comes from multiplying the 2a and the 2a together, so you end up with a denominator of 4a squared, of course. And then you end up with a difference of two squares, negative b minus the square root of b squared minus 4ac multiplied by negative b plus the square root of b squared minus 4ac. So that's your a minus b, a plus b type case, difference of two squares. So expanding that, you end up with 1 over 4a squared outside of b squared minus 4ac, so that would be in brackets, so that's it over there. I'll just move the board up slightly. So you end up with b squared minus, okay, so in brackets, b squared minus 4ac, so the b squared and the b squared will cancel. That 4 will cancel with this 4 here. This a will cancel with the squared, so you end up with just an a left in the denominator there. And then you end up with just c on a. So therefore, alpha beta is equal to c on a. So this is just another way to see that the product of the roots is just equal to c on a, and the sum of the roots is equal to negative b on a.